What if you could manufacture anything on your own? Let's talk about it. But first, I want to thank Maggie for the great job she's been doing to help others in need. And of course, for giving me the opportunity to be here today. I'm happy for being in this gala, but I'm also happy because I'm living in this period of history where so many changes, developments, and new technologies are arising. Luckily, thanks to my job in innovation, in the last decade, I've been in the first row to witness so many disruptions. And 3D printing is one of them, and it's the matter that brings me here today. But before continuing, let me clarify some concepts. When we talk about 3D printing or additive manufacturing, we are talking about the process to create a physical object from a digital model in an automatic way by adding material layers over layers. The main components of this process are, first, the printer itself. There are many technologies or procedures available right now. Fused deposition modeling, powder bed fusion, binder jetting, laser sintering, just to mention a few. We find them in very different sizes, from able to print very small, tiny things up to buildings. The second component will be the materials. Nowadays, it means a complete industry. There are so many options available right now, like thermoplastics, resins, carbon fiber, metal, biomaterials, wood, concrete, and much more to come. And third will be the design, or the way we create this digital model. This technology has brought a new way of thinking and designing, because usually the design is constrained by the production process. So it means that now designers have much more freedom to just come up with interesting or more complex designs and shapes and forms. Of course, also 3D scanning is also one more source to get this digital model, especially when you want a replica of an object. But this isn't new at all. We can find the first patents back in the 80s, but it wasn't until around 2010 when the hype started. When it comes to construction, the first patents or the first attempts to bring this technology to the larger scale and using cementitious materials are around 1995, when Professor Kosnevich patented the contour crafting system and later developed in the South California University. Also in 2005, Italian inventor Enrico Rini took the powder bed system also to a larger scale, using inorganic materials. In the contour crafting technique or extrusion, just to be more general, there is a mortar or a microconcrete or mortar that it's extruded through a nozzle that can be moved in a three-dimensional space by means of a gantry system or a robotic arm or a telescopic crane or even cable system. It's the same as long as you can move this nozzle in a three-dimensional way. And this extruded mortar is going to create the contour of the object that you want to print, and going layer by layer. So, where are we now in general for the 3D printing technology? Well, it depends on the materials, applications, and so on. There are different situations right now for every technology. Rapid prototyping, for example, is one of the most advanced applications, and also one of the first at the beginning. It was the most used for 3D printing. With rapid prototyping, small companies can easily print and touch and have this feeling of their products and reduce the time to market, for example. What else? Do you want a 3D printer for yourself, just to experiment at home or play a little bit? There are plenty of options that you can start, right? So you can start right now. If you just want a 3D printed object, you can just upload your model and have it printed, thanks to hundreds of websites that are already providing this service. In the medical sector, it is applied, for example, to manufacture 3D printed prosthetics that fit perfectly on the user, and maybe they are lighter than traditional ones. We have seen also some advances in printing using biomaterials that we can say these are the first steps to create human organs. On the other side, at this moment, some commercial aircraft are already flying with tens of 3D printed parts that reduce their weight and ultimately their emissions. Regarding production of final parts, if we think of small to medium batches, it has become competitive in 3D printing in front of the production with injection molds. In other words, let's imagine we need to produce a small plastic part. We start with a mold that costs, let's say, $10,000, and every unit produced costs 20 cents in material. And on the other hand, the same part 3D printed costs $20. In this case, that could be a real case. If you produce less than 500 pieces, it would be more cost effective to do it with 3D printed technology instead of injection molds. This way, the logistic industry will completely change, as we are not going to transport goods or products, but only raw material, and you will print on site. The stocks can be also minimized, as you are going to print or produce on an on-demand basis. In fact, now we talk about digital inventories, where we have the 3D models just ready to print. In relation to the construction and the use of cementitious materials, we can find applications in a long range, going from urban furniture like benches, or bus stops, fountains, or similar. We see also in the cultural heritage field for preservation, restoration, and dissemination purposes. We see some special structures like bridges with complex designs becoming possible now thanks to the freedom of forms that 3D printing brings. We also find a few examples of 3D printed houses and offices already around the world. And hopefully soon some schools, which is the main subject today, of course. Regarding 3D printing for construction, the main advantages are the automation of the process. We can increase the speed of the construction. We can reduce the cost as well. We reduce the use of the material, as we don't use formworks, for example. And additionally, we can add features to the building without necessarily taking more time or making it more expensive. Think of a green wall, for example, that you can have it in the design and just have it 3D printed at the same time you're printing the walls. Think of a shape that creates some shade on the walls, reducing the heat inside the building. Or maybe collecting rainwater. So this is all the present. But what about the future? For me, it's clear. There is no single industry that involves a manufacturing process that is not going to be affected by the 3D printing. It could be in a positive way or not so positive way. But I think it will depend how the industry or the companies embrace this change. We will see some point in the future that we won't go to shop shoes, for example. We will download them and print it at home. In the construction, 3D printing together with some other technologies like artificial intelligence, inspection with drones, augmented reality, IoT, will bring us someday to the human-free side. So, takeaways. First, a concept. 3D printing is about creating a physical object from a digital model, adding material in layers in an automatic way. Second, applications are virtually infinite when it comes to produce or manufacture some goods. Third, materials. It's continuously evolving and there are so many materials available right now, you just need it. So, 3D printing is here to stay, no doubt. Okay, that's all from my side. I hope you can get some insight for 3D printing and 3D printing in construction. And thank you for watching.